RINEX into FAIR data objects. Thank you.
So I will talk about the case of the Historical Data Center and explain how we make it fair. The Royal Observatory of Belgium has been looking into ways to apply the fair data principle since a couple of years. We did that in collaboration of the data stewards of the University of Ghent. The goal is, of course, to enable and enhance the reuse of data by both human and machines. We shared this experience within UF. We had a couple of splinter meetings, and in 2001 we had a resolution that encouraged our community to adopt the fair data principle. In this presentation, I will show the results of the implementation of the fair data principle on our EPN Historical Data Center. And this data center is the archive of all the daily RINEX data from the EPN stations, and we built it to be as complete as possible. So that means that we actively looked for historical data, even before the station was included in the EPN. We have in total a bit more than 500 GNSS stations, 2.1 million files, and everything is available online on our websites. And it's a standard EPN. IGS EPN Data Center. And the goal is to build, to implement the FAIR data principle on top of it. For this, we need to create FAIR digital objects. So we have our data. Yeah, maybe I will not use this. And then we have several other layers that are the metadata, access services, and persistent identifier, and I will go through all of them. First, I will start by the access services. They are built for both human and machines. So for human, we developed this new data portal with some very basic search capabilities. And once you search for it, you get your results. And there you can either, you have access to different links concerning the station, but you also have access to web services in there. And then when these web services can be accessed from the portal, but also directly because it's standard RESTful API. They are organized in 3 different categories, level. We have the RINEX file, station dataset. What we call a station dataset is all the daily RINEX file data for the station, and then the data repository. So in the RINEX file, you have first URL of the file because you want to download it eventually, and then a lot of different metadata, the format, file size, modification date, the MD5 checksum of the file, and then you can have a link to the metadata of the station, and that is hosted in the station dataset. And in the station dataset, you have the metadata to how to get the GDCML, IGS site log. You have information about the DOI data license, and you have a link to the RINEX file because you have the overview of all the available RINEX data. And then you have a link to the repository, and in the metadata of the repository you will have the publisher, metadata for network coverage, the type of data, and you have a link back to the dataset with the list of GNSS stations with dataset. Of course, we have some documentation for this API. And here it's an example. If you want to query all the files for the station Alcor in Spain between 1996 and 2023 that have changed after July 2023, and by querying that, you will get a list of files. So that's nice, but it's not fair. And if you want to have something that is fair, you need to change your query and to ask for a JSON LD, and then you will get something a bit more rich and standardized. And that leads me to the next point, which is about standardized and rich metadata. Rich metadata is everything the user needs to know and all the information required to apply FAIR data principle. We need that because it will allow to facilitate search and provide all the useful information we need. And we did it by changing the curation of the data of the RINEX and storing all the necessary information in a new database, and also by exploiting the GNSS station metadata system we have in our hosting the M3G, and there's a poster about that if you are interested. And then second part is standardized metadata. It's because we need something that is reusable and machine readable by construction and easy to be converted in other metadata standards. It's required by the FAIR data principle to enable interoperability and reuse by both human and machines, and we did it by building a standardized metadata schema that is called GNSS DCAT AP. And GNSS DCAT AP is a DCAT application profile. So basically it's a cookbook, it's a set of metadata elements, policies and guidelines used to create a standard metadata schema for a particular application, in our case GNSS. And it is built on DCAT, and DCAT is a W3C vocabulary designed to facilitate interoperability between data repositories. So it's exactly what we are talking about, data repositories. You can find GNSS DCAT IP online, and I will show you a bit how it looks when you query for one file, for example. And you will get information. So the first one is, no, maybe not best. The first one is about the status of the file. So here in that case it's completed, and you have information about the compression, the last modification time. So you have the link to the file, so you can find it, of course. You know that it's a daily file, and then you have a link to the dataset. And it's where you will get all the information about the station metadata. So now we have metadata, access services, and I will go for the persistent identifier. It's what gives you long-term reference to the data and metadata. And within JGOS, the Committee on Digital Object Identifier for Genetic Dataset agreed that DOI for dataset of GNSS station is necessary, that the DOI for network should be also allowed, and of course they can be linked together. And for this, we started to, we built a tool to collect all the existing DOI for the station we are hosted in M3G. For both the stations and the network. But it appears that there are very few of them inserted, and there are a need from the station manager to have some help to mint such DOI. And therefore we developed a new on-demand service provided for now only for the DOI stations to export some harmonized and standardized DOI metadata sites DOI metadata, data site metadata, sorry, and a landing page. They follow, of course, the GGOS draft recommendations. It's based on all the information we have in M3G. And then from this, either the DOI can be minted by the central bureau or by a station manager. At the moment, we have already 118 EPN stations for which we have a station DOI. And we hope that it will increase soon because we had a resolution with the UF to encourage the station manager to mint such a DOI. This is an example of the landing page, and we tried it in the Fuji tool, and we had a very nice result of 83% of fairness, so we were very happy with that. So we implemented the FAIR data principle on the GNSS RINEX data repository we are hosting, the EPN Historical Data Center. It's an IGS style data center. So around the data that are the RINEX data, we built those different layers. So we have our standardized metadata schema, which is the GNSS DKTAP, and it is exported in JSON as serialization formats. We built some access services for both human and machines. So we have our web portal and some web services in REST API. We developed several services to provide persistent identifier for the different objects we are hosting. And of course, there are some work to be done, still to be done. We would like to populate the additional optional metadata field with information like the GNSS data quality indicator, the file provenance. Our web service, it's the first version, so we are working on extending the search capabilities. For the web portal, we would like to improve the user-friendliness and provide more examples. We already have some that are available, but we would like to have more. We are thinking about implementing a user authentication usage of web services, and the GNSS DKTAP we built is modular. It means that new classes or properties can be easily added, and like for example for the GNSS project. So you can have more information online. You have a lot of documentation available there, and I would like to thank you for your attention.